groupings. So guys, naturally, I mean, this is the indication that we are heading the discussion in the right direction, right? Like Niranjan was also asking the same question, and Udbhav and right now Sundar is also asking those questions, that the streams or the data, now that you have said there is a parallelization, there might be multiple instances, or forget about parallelization, even if let's say you are going to have single instance also, but if you are having multiple, let's say spouts, multiple bolts and all, how exactly the data is gonna flow? So when we talk about it, basically there are multiple routing schemes come into place. When we talk about routing schemes, these are the routing of your data or the input stream altogether. So that's why we call them as stream grouping. Stream grouping stands for the routing schemes, okay, routing schemes of your streams, the or the input data stream which is flowing within the cluster. There are multiple kinds of groupings which are possible in Storm. Like you right now it shows basically. So on the left hand side, the top one, stream grouping, actually it is not the type of grouping. All of the remaining ones, shuffle grouping, fields grouping, all grouping, direct grouping, global grouping, none grouping, custom grouping, all of them are the types of stream grouping. Okay, is that clear? Now coming to what exactly which grouping does what, and when you should use, you know, a specific one. That is something we'll talk now. Guys, just a sec. I just need a bit water. Sorry. Okay. I'm sorry, I'm having a bad throat. So now, stream grouping, it's all about the same kind of question, right? That before you design a topology, it is very important for you to know, or if rather than know, it is very important for you to define how exactly the data is gonna change. In fact, after this, you know, once I cover the grouping, I would give you kind of, so there are one kind of assignments which are there in LMS. And then there are some kind of assignments which the instructor also gives you, right? Like try it by yourself kind of examples, right? So many a times the best way to learn a new thing is by destroying it. Of course, keep a backup, destroy it, and then make it rework, right? So I'll give you a kind of small assignment altogether. So the important thing is, if you do not define your streaming correctly, then does not matter whatever is the business logic you have written. Okay, like you might have written a perfect business logic, but it might not give you the correct answer because it might not be getting the data properly. Okay, so we will see such an example. Okay, so stream grouping is just that, the basically as I have told, stream grouping, all the kind of groupings are the type of a stream grouping. So first example which you are seeing right now is about shuffle grouping. Okay, so see this, in the preceding code block, the bolt is set on the topology builder. Okay, and then the source is set using the shuffle stream grouping altogether. So what does it really mean? It just says builder dot set bolt. Okay, the bolt name is word normalizer. Okay, it is just a name of a bolt, word normalizer, and this word hyphen normalizer is the alias. Okay, so we Storm allows you to give some sort of unique IDs or some sort of aliases, but at the same time, right, at least till now, it is the responsibility of the I would say author or of the coder to keep these names unique within a topology. Okay, it's not across, but within a topology, the names should be unique. Otherwise, you will get an error. Okay, I mean, so that is one thing. Now, what you say is, it would get the data from its source via shuffle grouping, okay, via shuffle grouping scheme, and the source name is word reader. Okay, the source name is word reader. Word reader would have been defined somewhere else. Do not worry about that. Do not worry about that, because in the spout and bolt I'm going to cover this part. But right now, assuming that word reader would have been a source or word reader would have been a spout, right? This is where you are defining a shuffle grouping. Is that clear? Shuffle grouping. What does it do? I'm coming to that also. I'm coming to that also. But the overall premise of this slide, is that clear to you? Okay. What is word normalizer? Word normalizer is a bolt class. Okay. It's the name of the bolt. And word reader is the alias. See this actually these two lines are showing three concepts. One, declaring a bolt. Second, giving the alias to the bolt or any other component. Third is putting them together and defining the source itself. So in this, probably I could have written new word normalizer. I could have written that. Oh, sorry, new word reader. I'm sorry, Sundar. New word reader. I could have written that, but I have just said word hyphen reader, because in one line somewhere in the code, I could have already written word reader as new word reader itself. Okay, Sundar? Not only to Sundar, it is the point to, to Niranjan, Arpan, everybody in the class. Right? Now, about the shuffle grouping. So when I said shuffle grouping, very good. What does it do? It is many a times, it is called as the load balancing kind of a grouping also. Okay. Now what it does is, this grouping takes care that if, let's say, there are multiple instances of the bolt which are running, or if this grouping is supposed to send the, let's say, the records to multiple bolts also, okay, it just makes sure that it will randomly choose the bolts, whatever are the downstream bolts, it will randomly choose them. Only thing is, it will make sure that yes, all of the bolts should receive equal amount of tuples or equal kind of tuples. Okay, so let's say if there are four tuples which are coming, it would try to make sure that okay, 2 tuples should go to one bolt, another 2 tuples should go to another bolt. If there are 5, then probably it is like 2 to 1, another 2 to another bolt, and probably 1 another to the third bolt kind of thing. Okay, so it is randomly choosing the input streams, okay, and then sending them to the different instances of bolts, making sure that all of them get the equal load of data. Is that clear? What it is doing. Now we'll talk about when it is useful, when it is not useful. Right, guys? I'm actually, making sure that yes, these things should sink in right now. Okay. Okay, so only Udbhav has said yes. What about others? Like entire class is great. Okay, where is the spout in this grouping? Vishnu, when you say where is this? Okay, Sundar, yes, I'll take your doubt also. 1 second. So sorry, Vishnu, where is the spout in this grouping altogether? So you can, okay, this is the big mistake. This source component, actually this is basically your spout itself. Okay. How does randomly distributed tuple or randomly distributed, rather than tuple, I would say randomly distributed scheme probably, right Sundar? This is what you wanted to say. We'll make sure that the transaction is consistent. Okay. That exactly is the point of use case. So it is, shuffle grouping is useful only to do the atomic operations. When I say atomic operations, okay, you got the tuple, you got a tuple delivered to one specific bolt, one specific instance of bolt. Now, definitely Spout does not take care, does not really worry which bolt instance it has delivered the data, as far as the processing has not failed. And the bolt which would have received the data also does not care whether I should get the the data from different other bolt instances or not, right? So it means definitely if I have to do a kind of operation wherein I might be needing the data of other tuples also, right? I cannot use this streaming. I cannot use the shuffle stream if I, so what would be the simple example of this this scenario? Anybody? So what I'm trying to say is, the use case, give me a use case where you think you cannot apply shuffle grouping. Okay, Arpan, you are going, yes, your example no doubt is very good. So only thing is, your point is you are giving me the example where you can use it. I'm asking you the example where you cannot use it. Like Sundar has mentioned a point. Okay. So Sundar, what do you think? I mean, probably it's a reverse question to you. Yes, yes, Sundar, I'm coming to the example. I'm just trying to see if the class gives me the answer or not. Okay, Sundar, very simple example. Very simple example. Take this word count. Why? So why do you think we keep taking word count? Why do you think we keep taking word count as example? Because this is a very important example or very strong example even in the text analysis, text mining and all. Okay, so all of the times they just count the words, I mean frequencies and all, find out TF, IDF, etc., etc. Those are the things. But now in the word count example, so let's say I have a word called Sundar, right? I should make sure that all the words which are having, I mean all the words which are equal to Sundar should go to a specific bolt, right? Specific bolt instance, right, Sundar? Until and unless all of them go to a single node or to the single instance, I cannot reliably tell the word count which is for Sundar, right? So let's say Sundar appeared 10 times, 5 times. If I use shuffle grouping, then what would happen? If let's say there are 5 such instances of bolt, so Sundar, I'm giving you the real-time example here, okay? So 5 instances have been created for bolt. Now you are sending this tuple, right, Sundar, using the shuffle grouping. What would happen? 2 each will go to each bolt, right? Sundar, you are there with me, right? Then what would be the output? Your output would be 2 5 times, right? But it is a distributed system. It is not like MapReduce wherein you will be merging them together, right? It would not happen. So is your count correct? Your count is of course not correct, right? So this is the example where you cannot use shuffle grouping, right? Definitely shuffle grouping cannot be used in the word count example. Okay, clear, right? Now, so where I can use it? So example would be, I would be taking the name, okay, Sundar or something, right? I would take the name Sundar and I want to perform a check whether this guy Sundar, and let's say Sundar hyphen his SSN number. Okay, so Sundar hyphen his SSN number. Then I want to take now this record or this word. I will take the SSN part of it and I want to perform a checklist, right? What is your CIBIL score or what is your FICO score? Something like, right? your credit score altogether. So what exactly is your credit score? If I have to check, probably now if there are 10 instances of Sundar, right, and using shuffle grouping, 2 are sent to one bolt, 2 are sent to other bolt, 2 are sent to other bolt, and so on and so forth. Does that matter? Does that matter? Sundar, I'm now giving you the example where it is being used, right? So I have changed the very same scenario. Sundar, you are following me? And not only Sundar, others also. Hello? Right? Sundar, it is still not clear. Okay, not a problem. Sundar, can you come on there? Can I put you on there? Sure. That's great. Hi, Sundar. Hi, Sundar.
Hi, Vishal. Good morning.
Yeah, very good morning. So Sundar,
actually, yeah.
Let me then straightforward take you. See,
Yes.
Word count is clear, right? To you, like, let's say I wanted to that is clear, right?
Clear. That is clear.
Now my next point is, so again, word Sundar came multiple times in a text. Okay. Now only thing is, instead of Sundar, probably it was like Sundar hyphen your SSN number. Okay. This is the text. Okay. Now my purpose is not to do a word count. My purpose is to take whatever text is coming, split it in on hyphen, take the second part, which is SSN number, and check, let's say, in a lookup directory whether this SSN number is blacklisted or not.
Okay.
Got it? Now, if I just if I just do this and I send it to all the bolts, right? So now Sundar came 10 times, to each bolt it went. Now does it matter? Because every time that name hyphen SSN will go to a particular bolt. Every bolt is going to take your second part of the string and is gonna do a lookup, probably through an API or probably via, let's say, some sort of hash map which is maintained, kind of thing.
Yeah,
right?
yeah.
That is the case where you do not need the you do not need the count, or you do not need the records of other bolts, right?
Okay. Yeah.
So the second case is the example of shuffle grouping, where you can use the shuffle grouping, and that exactly is shown in the first point here. It is useful for doing atomic operations. The operation which I did the second time is the atomic one. On your record, one time I'm interested into. That's all. I don't care how many times it came. Right?
Got it. Yeah.
So I hope that difference is clear completely. Right?
Thanks, Vishal.
Okay, Sundar. Sure. So guys, I hope it is clear to everybody else also. Not a problem. So Niranjan, I hope you got the gist of what you lost, right? So Niranjan was offline for some time because there was some power problem. Niranjan, all we were discussing is the use case of shuffle grouping. Okay? Clear, right? Now, Vishnu is saying, so where there is no dependency on the previous transaction, then the group shuffling. No, it is not group shuffling. Okay, shuffle grouping. Vishnu. Okay, so it is shuffle grouping. Yeah, it is like, burning train to turning brain. Sort of thing. So, sorry. But just kidding. It's like the same name. Okay, shuffle grouping. Okay, so is that clear? So now I'm extending the very same example. By the way, it was a question from Sundar, so that got clarified. I hope this discussion helped everybody else also to understand the difference. Now my point is, I'll go back to my word count example, right? So clearly I cannot use shuffle grouping for word count. That is very, very evident to all of us, right? So then what exactly is required. Then our requirement will tell us about the next grouping. Okay, so the requirement is, so I'll take the very same example of Sundar. This word came 10 times. I need that all of these 10 words, Sundar, should go to an instance, should go to a single instance, right? That is my requirement. Shuffle grouping definitely is not the answer. So in order to cater for this requirement, Storm provides another grouping that is called fields grouping. Is that clear? Fields grouping. Okay, so Sundar, this is the answer for the second thing, where you are dependent on all of the elements of a single key to come together. Now, my point would be, now that I have given you one example of word count, not the assignment, right now the exercise for the class is to tell me what is the other use case of field grouping. Give me one more use case of field grouping. Okay, very good. So to find the maximum temperature, to find the average of the transactions, very good. So Sundar, Udbhav, Arpan, you all are right, and at the same time I should say you are all clever. What you have done is, you have seen word count is group by count. So let me give the example of group by sum, group by average, right? So this is quite clever, I would say. But now let me change the scenario. All of this, you gave me the example wherein your spout was emitting the records from a single source. What if it would be emitting the records from multiple search sources? Can you think about it? Yes, Vishnu, that's correct. All of the examples which you are giving are good, but now I have changed it. See, the whole idea of spending time into it is code and all. Once I give you the structure, you would be good. There is hardly anything which will change. Okay, what will change is these settings. Still it goes to the same volt. Correct, correct. But see, I'm asking you the other scenario wherein if it is coming from multiple data sources. Okay, I'll give you the kind of scenario. Probably the scenario might be, I might have to perform a join. Right? Guys, Sundar. So all of you who were just thinking, see, understanding Storm is not a big deal. Okay, but understanding how to implement it is something where it takes time, right? This is one of the clear cases. Arpan, Vishnu, Udbhav, Niranjan, everybody, right? Join. Isn't it the simplest example? Real-time joins, right? Exactly. Pattern matching, exactly, yes. Makes sense, makes sense. Exactly, yes. So basically, yes, you can group by the field and all, exactly. So the seed which I'm trying to plant here is, don't really think from a single data source perspective. Okay, start thinking from the multiple data sources perspective as well. Okay, because in real world you might be facing these kind of things. Exactly. Yes, Sundar, that's correct. So I hope this discussion is helping you, right? Now, whatever were the missing points, right? Those are becoming clearer, right? That was the whole idea for me to go slow. I could have covered it in the last class also. So, see this. This is a typical case. Now, I'm showing you this example. I think this is how you will see in the word count example source code also. What I want you to do is, you'll see that fields grouping. Okay, so how do you set it? You will set the bold. Of course, there is nothing wrong about it, but then see this new fields word. Right now I'm saying fields grouping, so the data would go to the word normalizer, right? I'm not changing the example here, guys. The same thing, word normalizer, but this time it is receiving the data via fields grouping. And in the fields grouping, I'm specifying basically word. So word is what? It's my schema. Now what is the schema? Right now, just for your own understanding, just assume that whenever the spout and whenever the bolts basically emit the data, they can declare the schema. This is how my data looks like. Okay, so your word count basically is going to, of course, word count, what would be the output? The output would be a single word at a time, right? So it has declared the schema as simple word itself. Okay, so the moment you will say field grouping, now tomorrow it could be a composite also, word, comma, word 1, comma, word 2, comma, word 3, etc., etc. Okay, tuples data model, exactly. Yes, yes, Sundar, yes. Seems like, so there are so many people who have read quite a lot of things, and probably you have gone through Hadoop courses also, so that must be helping you. Now, guys, may I take a confirmation from the class whether it is clear, because then I can happily move to the next grouping. Great, thank you. Now next is, okay, next is all grouping. Now this is the kind of grouping. Okay, so this is very good. Now simplest way, don't read anything, don't read anything on this slide, just look at the picture. What is happening here? What is happening here? All grouping. Correct. I have got one answer. Very good. Second answer. Both are correct. So simple, guys. This is the grouping wherein you are sending each tuple to each day, each bolt instance altogether, right? So everything is sent to everything. Okay. What is it called? It is typically called as broadcasting, right? Right, guys? Now, my point is, why do you think you should do a broadcasting? So what I'm trying to achieve, why these, so specifically only for the Storm class, I have changed my teaching style. Normally I go for a, explanation and then discussion. Right now I'm even changing the explanation part, wherein I'm trying to convert it also into the interactive mode. So that since it's a new concept, right, the better way would be you yourself would be able to think what would be the use case, rather than third person telling you or the second person telling you about it. Sundar, Arpan, temperature data to all TV station. Okay, in chat development, all the messages need to be sent. Exactly. So Niranjan, chat development and all, are you going to use Storm? Right? Those are the kind of things which you have to think. So I'm saying, give me the real kind of scenario. Sundar's example, definitely yes. See, okay, I would say, I would try to give you one simple example. Let's say you are trying to maintain some sort of state altogether, or rather than state, I would say you are referring to a specific cache which is built, right? Memory, some sort of memory which you have built by reading a particular file, right? Now some change has happened in the configuration file or something, right? Some contents have changed in that file, which was being looked up. So like Sundar, I was giving you the example, right? SSN lookup, right? So your SSN, every time it was being looked up by all the bolts, right? Now that lookup got stale, like some changes have happened, right? Now this lookup has to be refreshed for all the bolt instances, does not matter whatsoever are referring, right? If you have to do that, right, so that next time unnecessarily, probably this time your name is in blacklisted node, next time it might not be in blacklisted. So it means your configuration or your lookup files have to be refreshed over the period of time, right? This is where the concept of all grouping will come. So those tuples, you can use all grouping in those cases in order to send the signals. Typically it is called sending the signals altogether. Right, right, Sundar. So Sundar gave a nice example, defaulter list to the bank. Right? So guys, is that clear? Because now next would be the code of it, which is something I would not speak much on it. Can you please give me more example where we will be using all grouping in Storm? I think we just discussed 2-3 examples. One was clearing the cache. So let's say you are doing a lookup arpan into a hash and all, and that. So I'll give you this example here itself. See this. So this is basically is happening within a bolt itself. Okay. Vishnu, just a second. It is not really that we are using all grouping for the word count. We are definitely not using the word count. Only thing is just to keep, okay, just to I would say keep the base code same. If I just keep changing my code again and again, right, it would just create confusion. That's why we have just taken the same this thing. By no means you are going to use all grouping in the let's say in the word count. The only case where you can use, I mean technically you can use it. So what you want is each and every bolt instance should give you the overall word count every time, right? If this is the scenario, probably you can use it. But then practice, I mean logically it doesn't make any sense, right, Vishnu? Vishnu? Only thing is, what we are trying to show here is just in case if you wanted to use, this is how you'll be using it. Okay. Vishnu, I'm waiting for your response. Probably if you're typing or something. Okay, it seems like you're still typing. Okay, not a problem. So now, if you see this, what are we trying to achieve here is we are getting basically the input stream altogether, and this is where it is important. See this, if input dot get source stream ID dot equals signals. This is just a simple example wherein we are saying was if your source alias, now this is something which is important, just check. See this, these are the aliases, right? Word count normalizer. And if you want to refer them on a later date, you can use them as get source stream ID. That ID basically is assigned to the particular source itself, okay? And you are just going to assign it, and you are just seeing if this particular, you know, the source of the stream which is coming to me is from signals, then do something. And what are you trying to do? You are just trying to probably create, I mean, you are just seeing if the action value is equal to refresh cache, then you are just going to clear some counters. That's all. Okay. Vishnu, first of all, are you all able to hear me? Sundar, Arpan, Udbhav, Vishnu, right? So Vishnu, is that point clear to you that it is not really the case that you need the all grouping in word count? It is just to keep the same code base. We have taken the very same code example itself. Okay, that is point one. Second, the idea here is the source code which we have shared with you is, it just tells you how to use it. So you would be doing all the, all grouping and all, but in case if you want to use it, this is how, wherein you will see that, okay, now kind of just first of all identify from which source you are getting the data, and based on that, whatever is the value coming in, you may or may not decide to perform a task. So here what we are trying to see is, if the source of my stream is signals and the value is which is coming is equal to refresh cache, okay, then I have to just do some counters dot clear itself. Okay, otherwise don't do anything. Sundar, Niranjan, Udbhav, right? So Arpan, is the example clearer to you now? Vishnu, I'm still waiting because it seems like you might be having some doubt. Okay, this example is clear, right? Okay. Okay, now it's clear. Okay, thanks. Now, so basically Storm gives us the possibility to declare the named stream. That exactly is something which you just saw, like those IDs, right? Those aliases were the IDs, and how exactly you can access them. Basically get stream source ID. These are the inbuilt functions which Storm provides you, and you can. So the reason why I'm using this all grouping, or why I'm focusing on the possibility of declaring the names, because the next grouping, or probably next to next grouping, is gonna use the very same. Okay. By the way, these are like important points. Okay, this is very important. Do not, if you do not assign, by default the stream ID would be default. And then that's why we say that it is a good practice to give a name. Reason is, if you do not give, then even if your data is coming from multiple sources, in the bolt it would not be able to identify from which stream the data is coming to it. Okay, then it would give the same treatment to each kind of data. Okay, I'll come to this grouping later. I first want to complete the direct grouping, and then I want to go for the custom grouping. Okay, the reason is, custom grouping is the one when you are not satisfied with any of the groupings, right? And you want to create your own grouping logic. What is the default partitioner in Hadoop? That is hash partitioner. But many times, right? Many times, if you want to create your own partitioner, you create your custom partitioner, right? Right, guys? You apply that get partitions method. Basically, you implement that, right? Same thing is applicable in Storm by custom grouping. So that's why I'm saying I'll cover it immediately after the direct grouping, because this is one of the inbuilt under grouping which is available. Now, guys, when it comes to the direct grouping is the one wherein you send the data, okay? You send the data, the source knows what is the destination, okay? Here, the source itself decides the destination, okay? So how does it happen? And whenever you'll use the direct grouping, in fact, yes, whenever you'll use it, you will be getting it like kind of just a sec. Okay, that's fine. So the source here itself is going to decide which component is going to receive the tuple, and as you can see here, instead of using collector.emit, this, okay, you must have seen previous examples. No, you have not seen. That's fine. Custom grouping, direct grouping. So guys, when you emit the data from a tuple, from a bolt or from a spout, you typically use the method called collector.emit. Okay, that's the method which you typically use. But here, if you have to use your direct grouping, you will be using emit direct method instead of emit. That is point one difference. Second is, how do you decide? So what you say is collector.emit direct, and then you have to apply get word count index, or I would say this is just a method which will apply. And just have a look here. First of all, let me just put the code together, then I would be able to tell you more. So it is public integer, this thing, get word count index. Okay, it gets the word, converts it into the uppercase. If it is 0, then, I mean, if there is word is nothing, right, then it returns 0. Otherwise, it returns you the modulo of word.char at 0 percentage number of counter tasks. Okay, num counter tasks. Now, what is num counter tasks? Okay, what is num counter task? Hold on. For this, we have to go to the next slide. Now, the number of target tasks are defined by the prepare method. Now, some of you might be thinking, what is prepare method? It is one of the methods in bolts. I will be covering it when I'll go to the bolt side also. Okay, but here, coming back to this point, on the bolt side, there is a prepare method. What it does is, you can directly get the number of tasks for a given source just by supplying the alias of it. So you remember this ID, right, which we created is so useful. So word counter, let's say it is the word counter is the direct descendant of this bolt. You will just say how many tasks or how many instances are created. If you want to know the number, you will come to know the number by context object itself. And how would you do it? You would just say basically context.get component task for a given counter. Is that clear? Is that clear? Udbhav says it is clear, but I was looking for some sort of confusions here. So what I'll repeat it once. You got the number of tasks. Based on that, you took the modulo of the first character, right? And you just returned it all together. Then in the main topology class, what you are going to do is you are going to say word counter, and it is related to the word normalizer by direct grouping. And within word normalizer in the execute method, you are going to basically implement collector.emit direct. Okay, why would you do a modulo? It is all about just that you are seeing, okay, so I'll take the example of Vishnu. So what is essentially happening here? It is taking the name, it is converting it into the uppercase, and for the first character, right, divide basically modulo of total number of tasks it takes. So essentially here it is just doing a kind of field, not really field grouping, kind of field grouping. if I consider your first field as your first letter as the field itself. So all the names which are starting with V will have the same number, right Vishnu? Right Vishnu? Similarly, all the names which are starting with M or A or U will be having their different modulo altogether, right? Right? Vishnu, I am waiting for you. I think it would be better. So probably if it is not really clear, would you like to come on the air once more? Vishnu. Vishnu, I'm still waiting because I'm in between of explanation. Could you please respond? Okay. Okay, so I'm putting you on air. Just let me know what exactly is your confusion so that I can remove it. Okay. Hi Vishnu. Hello. Hello, Vishnu.
Yeah, Vishnu, can you hear me?
Yeah, Vishnu. Now I'm able to hear you.
Yes.
Yes, I can hear you. So Vishnu, yes, please let me know your doubt.
So in this execute, right, you're taking an input and you're emitting some kind of a number, right?
No, when I say emit direct, what I'm trying to do is, see this, when I say emit direct, see, get word count index. This would return a number to me.
Okay.
Right? Let's say 1, 2, 3, 4 for the sake of simplicity, either 1 or 2 or 3 or 4, right? Then what I'm doing is I am so this number I'm sending it whatever would be the name of every name would be sent to one of these 4 numbers itself. So all the names which are, let's say, starting with A and all the names which are starting with H or J or M will be sent to one particular Bolt instance. All the names which are starting with V and X and let's say B are going to be sent to a specific another Bolt instance, and so on and so forth. In order, so how did I decide? How did I decide the number of tasks? Right? I found the number of tasks using context.getComponentTask itself.
Okay.
So modulo, what it is, so first of all, Vishnu, you are aware of partition concept in Hadoop? That way it would become easier. If you are, not really sure.
Not really.
Not really, not a problem. So what happens is, in a typical distributed world, right, when you have to send the data to multiple, let's say, different machines altogether, typically what do we do is we take the modulo of total number of workers divided, modulo of whatever you want to send and the total number of workers which are available. That way it ensures that, boss, your record would definitely go into one of these workers altogether. That's it.
Okay.
Got the idea, right?
Yes.
Vishnu, right? So this exactly is direct grouping. Okay. So here, if you go, okay. So I think they have not included the picture. So what happens is all the names of V and all would go to a specific, let's say, kind of. I would say kind of Bolt itself. Okay, clear, right? Now yes. I'm coming to the global grouping. Global grouping is the easiest one. Anyway, thanks Vishnu. So I would request Vishnu and others, if you have the kind of question, you can just request me and you can come on the line and then we can just clear it off very quickly. Arpan, let me just first complete this global grouping, please, and I'll take your question, because otherwise the flow would be, disturbed. Now, global grouping, it's all about you have, I don't have to say anything here, right? It is many is to one relationship, right? So typically, if you use the global grouping, it's all about all of the data would be sent only and only to the single instance. It is like global grouping is something like a go-to statement. So it is available I have at least not shown, I have not seen any use case of global grouping as of now. Okay, so can you use global grouping in word count? Yes, yes, Arpan, correct. See, all those people who are from Hadoop background can easily correlate. That is what I uh, also was thinking. Right? Correct, Vishnu. Sundar, can you use global grouping in word count? Right. Okay. So it's all about, instead of shuffle grouping, you just have to mention dot global grouping. That's all. Okay. Now there is one grouping called non-grouping. Okay. Essentially, it is same as shuffle grouping. Okay. Then why it is called as non-grouping? Right now, this is the statement which is written even in the Storm site. Right now, it is same as shuffle grouping. It is reserved for some sort of future grouping which might come. Okay, so there is non-grouping is something which is, I mean, typically people don't use it because shuffle grouping is the one which solves the problem, but it is right now same as shuffle grouping only. Only thing is, in the non-grouping, basically it has been reserved by the developers of Storm in order to develop a kind of new grouping which might come in future. Okay, so non-grouping is, I mean, if we wanted, we could have removed it, but then again you would be referring some of the books here or there, right? And at that time you will find, and probably you might have said that Vishal has not told it to us. Okay, now custom grouping. As I said, custom grouping is the one which I'll explain. So guys, after grouping, I know some of you are asking for the break. Just let me complete the custom grouping and then I would be able to give you the break. Okay, just a second. Yeah, after that there would be only some small things and then we can go to the happier part of seeing it into the machine. That is something which I also like. Okay, about the custom grouping, guys, simple. You can have your own custom grouping, stream grouping. Okay, if let's say you are not really satisfied with, or probably, I don't know, tomorrow in near future you might have a kind of scenario where none of these groupings might help you, right? At that point of time, Storm allows you to extend its own grouping scheme to the custom one, whatever you want. Okay, so I was discussing with Vishnu just some time back one example, right? Letters which are starting with the same, all the words which are starting with the same letter would go to the same sort of bold. We have actually implemented the very same thing using custom grouping also. Okay, so this kind of grouping gives you the power to decide basically which bolt are going to receive which bolts altogether, but it is different from direct grouping, right? It is different from direct grouping because in the direct grouping it was simple modulo altogether, but that also, if it is not helping you, then the custom grouping is something wherein you can apply whatever logic you want to, and based on that you can decide which data should go to which bolt. Okay, so a simple example again of the word count itself. What we have done is all the words which are starting with the same letter should be received by, let's say, the same bolt itself. Then the answer would be this. Have a look, because continuously speaking is also not good for understanding. Have a look on right hand side, the highlighted part. Custom stream grouping. The class name is module grouping. Okay, so this class name could be anything: module grouping, Arpan grouping, Udbhav grouping, anything, but it should implement custom stream grouping. right? Now, see this. The one which you have to, so just like custom partitions, you used to override get partitions. Here, you will override choose tasks. Okay, choose tasks itself. And it's simple. It's like you'll just create some sort of, you know, bolt IDs themselves and values. Okay, just a sec. Now, so this is just code, some code which is not making much sense. Reason is, oops, what is happening? Some code is missing. Okay. Anyway, let me, oh, okay, sorry guys, I just got a bit confused. That's it. So first of all, this will tell how exactly Storm does internally. Storm finds out how many number of tasks have been set for a given topology. You remember number of tasks, you are setting it, right? Set num tasks, right? Those tasks are passed as a values here itself, and all it does is, sorry, not, I'm really sorry, this is exactly the string which is passed here, and based on that you just basically, again, the number of tasks, right, which are just integer number of, I'm sorry guys, hold on, seems like I have missed some code here. Where am I defining my number of tasks which are 0? Okay. Okay. Seems like guys, there is some problem here in this code. Okay, but I'm really sorry about it. I'll just check it. But anyway, the idea here is just like in the direct grouping, right? You got the number of tasks. Similarly, what would happen is your module grouping itself, what it would do is, it would, if you apply the choose task itself, it would get the number of tasks. This number of tasks would be equal to the number of bolts, the downstream bolts which would be running. Okay, and then these values would be basically the tuples. So it would probably just be the name itself, right? And what are we trying to achieve here is, we are saying string str is equal to values dot get 0 dot to string, means we are, let's say if it is Vishnu, then we are just taking the first one, right? I mean that entire Vishnu itself, and then we are doing string dot character at 0% number of tasks. Okay, and that is something wherein we are finding out what exactly is the bolt ID to which it should go. Okay, which bolt ID basically your data should go. That's where you will have to, basically you are just deciding what exactly is the bolt to which the given word should go altogether.